So today we're starting the last section of our Unit 10 inequalities by graphing systems of linear equalities. Make sure you have the notes that we did last lesson that started with lesson 10.7 where we were graphing just linear inequalities. We're continuing on that same note sheet. It's the last half of the section. Also, you're going to need your pencil plus something else because you're going to be shading and you're going to want to see where the shading overlaps because that's going to be your solution. So possibly a pencil and a colored pencil, but something where you're going to be able to see through the shading as we go. And as I do the first example, you can see what it looks like. Okay, so steps for graphing systems of inequalities. Graph each inequality on the same coordinate plane. Remember, if it's less than or equal to or greater than or equal to, it's a solid line. Those points are included in the solution. If it's less than or greater than, it's a dashed line, which means the points are not included. To find the solution to each inequality, you shade the correct half plane. Remember, if y is greater than or equal to, you shade above the boundary line, whereas if y is less than or equal to, you're going to shade below the boundary line. The solution to the system of the linear inequalities is the intersection of each half plane, which is where the shading overlaps. Example. Graph the system of linear inequalities. Give two ordered pairs that are solutions. And give two ordered pairs that are solutions and two that are not solutions. I think that should say, and two that are not. Okay, so the first linear inequality says y minus x is less than or equal to 3. I'm going to go ahead and add x to both sides. And when I do, I get y is less than or equal to x plus 3. I know this is going to be a solid line. I know that my slope is going to be 1 and my intercept is going to be 3. Okay, so I'm going to go ahead and graph this first. So I'm going to start on the origin and I'm going to go up 1, 2, 3. And from there I'm going up 1, right 1, up 1, right 1. I can also go down 1, left 1. And this is a solid line. I'll go ahead and graph that. And now I have to determine my shading, and my shading is where are the y values getting smaller from this line? Are they getting smaller this way, or are they getting smaller from that point that way? So it's like you pick a point and decide. So it's obviously below the line that it's getting smaller. So I'm going to go ahead and shade that. I'm going to shade mine in yellow. Okay, so we got all of that shaded. Now I'm going to go ahead and do my other inequality in green. 2x plus 3y is greater than negative 6. I'll subtract my 2x. I have 3y is greater than negative 2x minus 6. I'll divide by 3. Y is greater than negative 2/3 x minus 2. This is going to be dotted line, because it's just greater than. My slope is negative 2/3 and my intercept is negative 2. This time I start at the origin, I go down 2. From there, I go down 2, 1, 2, 3 to the right. I can also go up 2 and 1, 2, 3 to the left. And when I do, I'm ready to make my line. Doesn't really matter. We're not really looking for the point of intersection. We're looking more for the solution. So you can graph each one first and then shade, but I like to shade them and then go to the next one. Okay, so now it says where is it greater? So if I were to pick this point and I talk about where y is getting greater, y is going to get greater above above the green dotted line. So I'm going to do that in pink, and then I think it's going to show you where you'll see the change in color just the way it does here. And you'll see it just happens that when the pink goes over the yellow, it makes it orange. All of this orange, all of that orange is where they are solutions to the systems of inequality. So anything orange. All right, so let's talk about a point that is a solution and a point that is not. Any point in the orange is, so I'm just going to put a dot right there. Well, what is that point? That is 1 on the x, 0 on the y. So 1, 0 is a solution. Any other point that is not orange, I'm just going to go over here to where it's nothing shaded at all and pick this point. Well, what is that point? 1, 2, 3, 4, 5, 6. So this is -6. 0 is not a solution. Okay, so hopefully you can see how this works as we shade these systems of inequalities. All right, let's go and look at it some more. Practice. Graph the system of linear inequalities. Give 2 ordered pairs that are solutions. Give 2 ordered pairs are solutions and 2 that are not. So it looks like the word "and" got typed as "are" both times. Okay, so let's look at the first one. Y is greater than x minus 2. This is in slope-intercept form. It's going to be a dotted line. My slope is 1. My intercept is -2. So I'm going from the origin down to -2, up 1 over 1, up 1 over 1. I can go down 1, left 1. And I'm going to make my line, and I said this is dotted. Okay. And it says greater than, so I pick a point on here. Where are the y values getting greater? They're getting greater when I go above. I'll shade this one in pink since it's on pink. So this is where they're greater than. So this is, when you were doing just one of them, it's similar to what you did for homework, but now we're doing a second linear inequality on the same coordinate plane. All right, the second linear inequality is also in slope-intercept form. It's going to be solid. Y is less than or equal to x plus 4. The slope is 1. The intercept is 4. From the origin, I'm going to go up 1, 2, 3, 4. And from there, it's up 1, right 1, up 1, right 1. Can go down 1, left 1. This one's solid. And so I'm going to make a solid line right here. What do we know about these lines? They have the same slope but different intercepts. So that means that they're parallel lines. So that makes sense that they're not overlapping. All right, now let's look at where we're shading. It says less than. Well, if I choose a point, the y values of this point as I go up are getting bigger, but we want where it gets smaller. So I'll change it to yellow again. And that happens down here. That happens down here. The yellow is the second inequality. The orange is all the solutions to this system. So this says give 2 ordered pairs that are solutions. Okay. 0, 0 is a solution. Make it easy. And 0, 1 is a solution. 2 points that are not solutions. Let's do this point. I should have probably done it in another color. Let me do it in another color. Oop, it took my stuff away. Let's say 1, 2, 3, 0 is not a solution. 5, 0 is not a solution. And let me reshade what became unshaded. Okay, hopefully that's starting to make sense, but we're going to keep going. Let's do some more. X is greater than 2, and y is less than or equal to negative 1/2 x minus 2. So x is greater than 2, and y is less than or equal to negative 1/2 minus 2. X is greater than 2. This is going to be a dotted line. And it's going to be going right through 2. It's a vertical line. So I find 2. It's an easy one to do. And I'm trying to see my ruler here. It's not wanting to move very easily. Okay. So we said that's a dotted line. Got it. And then y is less than negative 1/2 x minus 2. That's in slope-intercept form. It's going to be a solid line because it has the equal to. The slope is negative 1/2, and the intercept is negative 2. And before I start doing this one, I forgot to do my shading. Where are the values of x getting larger? They're getting larger to the right of our line. So we shade all those. Okay, now I'm ready for my second line. I'll do that in green. Negative 2 from the origin is right there. Then I can go down 1, over 2. I can go up 1, left 2. And we said that this is a solid line. Get my thing going. Oh, there it goes. Come on, pen. Let's see if there it goes. All right. That's our other line, and it says, where are the values of y getting less? So if I take a point, and from that point I know going above they're bigger, so going below they're less. And you shade them all in. So again, where it becomes orange is where they are solutions. Okay. So let's do 2 solutions. Well, right on this line is a solution. So I'm going to show you because that's a solid line. Let's see. Let's go to this point right here. 1, 2, 3, 4. 1, 2, 3, 4, 5. So 4, 5 is a solution. Let's go down 1. Make it easy. 4, 6 is a solution. What is not solutions? Not solutions are 0, 0 and 0, negative 1. Okay, so let's see what we got here. Looks like there's 2 more, and these are going to have to be put in slope-intercept form first. They are not. So I'm going to stop the video and give you time to put those in slope-intercept form. And after that is done, go ahead and graph them, and then we'll look at, I'll come back on the video and have these done so you can see if you did them right, and then we will finish this last page. All right, so we'll be back together in a few minutes.